Yes, hello grade 11s. Good morning. How are you today? My name is Patrick Kamala. I am a tutor and educator for mathematics and physical sciences from grades 10 to 12 here at Rosteke College in Purukwane. And today I'm happy to take you through the last topic for grade 11, chemistry, that is redox reactions and applications for term 4. I'm sure if you pay attention, you'll scoop all your marks, okay? Yes, I send my learners in the center from Capricorn, Nulderland, and from what? From Meridian. Yes, let us start. Now, redox reactions. What are redox reactions? Redox reactions, these are reactions which involve what? The transfer of electrons, okay? That is redox. It stands for reduction and oxidation reactions, okay? Let us look at it in details. Now, this is a continuation of our previous video. If you watched it, please, I'm sure you're going to like this one as well. Let us start. Now, what's a redox reaction? What is a redox reaction? Now, a redox reaction is a reaction in which there is a transfer of electrons between elements. It is what? A reaction in which there is a transfer of electrons between elements. Okay, so it involves oxidation. What is oxidation? Oxidation is the loss of electrons. Oxidation is what? Oxidation is the loss of electrons. So in your test, if they say define oxidation, you say it's the loss of electrons, but you must know that at the same time, oxidation in number increases. Okay? Then what is reduction? Reduction is the gain of electrons. Also understand that in that case, after gaining electrons, oxidation in number decreases. Okay? And again, the oxidizing agent is the substance which accepts electrons. They're going to define oxidizing agent. You say it is a substance which accepts electrons. Okay? And then it is the substance which is reduced and causes the other substance to be what? To be oxidized. Okay? Hope we are still together. I'm trying to say that the oxidizing agent is what? It is a substance which accepts electrons and it is reduced and causes the other substance to be oxidized. Which substance is that? The reducing agent. Okay, so the reducing agent then is the substance that donates electrons. And then we mean, so it's the substance which is oxidized and causes the other substance to be reduced. Let me explain again. Actually, the oxidizing agent accepts electrons. After doing so, it causes the other to be oxidized. And then the reducing agent donates electrons. As it donates electrons, it causes the other to be reduced. Okay, now to remember these definitions here, we use what we call as oil and a rig acronyms, whereby oil stands for oxidation is loss of electrons. What about a rig? Reduction is gain of electrons. Okay, or you can also use LEO, which stands for loss of electrons, is oxidation, and then GEAR, which means gain of electrons, is reduction. So remember these ones here in your test, they're going to help you to get your marks. Now, what are oxidation numbers? In order to keep track of electrons during the chemical reaction, oxidation numbers are assigned to each element in the reaction. The oxidation number is similar to the valence of the element. Now, we have got rules for assigning oxidation numbers. These rules include the following. Okay, number 1, pure elements and diatomic elements, for example, oxygen, have got a 0 oxidation state. Number 2, hydrogen has got positive 1, except when bonded to a metal, for example, sodium hydride. Then it's going to be negative 1. Are we together? So talk about hydrogen in water, in anything else, it's going to be having positive 1. What about with the metals? Going to be having -1. Please take note of that. Okay, perhaps you want an example. Let me explain properly. Now, take an example of sodium hydride, for example. Sodium hydride, it is N, okay, Na for sodium. Then hydride is the oxygen here, hydrogen here. So now sodium has got +1, okay, and then hydrogen in this case is going to have -1. But talk about water, which is H2O. Now in this case of H2O, now because this is not a metal, this is oxygen, it's a non-metal. Now hydrogen is going to be what? Going to be having a positive, and because there are 2 here, you're going to have a 2 open brackets, then +1, meaning now it has got +1 oxidation state. What about oxygen? It has got 2 minus, as we are going to see, except with what? Except with the peroxide. Okay, hope we are together, guys. Let's continue. So oxygen has got -2 oxidation state, except in the peroxide, that is to say H2O2 is going to be -1, and when bonded to fluorine is going to be +2. Take note of that. I repeat, oxidation state of oxygen is -2, except for the peroxide where it's going to be -1, and also bonded to fluorine it becomes +2. Why? Because fluorine is the most electronegative element. Okay, then talk about metals. Now for the sake of metals, their group number is the same as the oxidation state number. For example, group 1 have got +1 oxidation state, group 2 have got +2 oxidation state, and group 3 have got +3 oxidation state. Hope we are together. The oxidation number of monatomic ions is the same as the charge. Are we together? We are saying that the oxidation number of monoatomic ions is the same as its charge. For example, talk about zinc 2 ions, it means going to be +2. Are we together? Because this is monoatom, this one atom, okay? So this +2 is the oxidation state for zinc 2 ions in this case. And then group 17 elements have got -1 oxidation states. And what are group 17 elements? Those are the halogens, including chlorine, bromine, iodine, fluorine. Are we together? Those are halogens, okay? They've got -1 oxidation state. Then rule number 7, the oxidation number of transition metals is indicated by the Stokes notation. For example, in iron 3 chloride, you see the 3 here, the 3 shows us the oxidation state of the ion, so that is +3 in this case. I repeat, the oxidation number of transition metals is indicated by Stokes notation. For example, iron 3 chloride, it is 3, shows us the oxidation state number for the ion, okay? Then in a neutral compound, the sum of the oxidation numbers is 0. We are going to see that in direct examples. As long as it is neutral, the sum is going to be 0. Then lastly, in a polyatomic ion, the sum of the oxidation numbers is equal to the charge of the ion. So if the ion has got many atoms, meaning polyatomic, then the sum of the oxidation numbers is equal to the what? Is equal to the charge of the ion. You're going to see that also in the example shortly. Don't worry about it for now. Okay, don't forget that if it is neutral, then it must be equal to 0. Okay, but if it is an ion, then we equal to the charge of the ion, which could be a positive ion or a negative ion. So we're going to see the examples. Okay. They say give the oxidation number of each of the elements in the following. Now don't forget our rules as we get these answers here. Let me explain this now. For example, now this oxygen, you see it is diatomic, and it is not reacting with anything, so it's going to be 0. Why? Because we said here that pure elements and the atomic elements have got 0 oxidation state. So that's why it's going to be 0 for oxygen in this case. Are we together? Then hydrogen sulfide, Now hydrogen, and now sulfur is a non-metal, so it's going to be positive 1 for hydrogen, okay? That's why it's positive 1 here. And then because of the 2 here, now sulfur, because you see this is 0 here, it means I must be having a 2 minus for sulfur, because you see there's no charge here, it is 0. In other words, for hydrogen I have positive 1, but as you can see there are 2 of them, so it means that 2, okay, then with the positive 1 must be balanced with what? Must be balanced with a 2 minus, which is going to be for what? For sulfur, okay? So this sulfur has got 2 minus. What about hydrogen? Positive 1. Now when I come to potassium permanganate, potassium being group 1 is going to be having positive 1 oxidation state, okay? And then manganese and then oxygen, like we said, except for fluorine and the peroxide, it will say it has got negative 2. So the one for manganese, let's say I don't know the answer, that is 7, and I want to find out. So I know for oxygen it's going to be negative 2, because this is not hydrogen peroxide and neither is it combined with fluorine, okay? So I can say let it be Y for manganese. Then I know for potassium it is positive 1. What about oxygen? Negative what? Negative 2. So I'm going to do my calculation and then equate to 0, because there is no charge here. Are we together? So in that case, I'm going to do something like this. Yes, it should be working here. I'm going to do something like this now. I'm going to say that potassium has got positive 1 oxidation state, that is 1. Are we together? Then for manganese, I said let it be Y. It's going to be Y here, okay? Then for oxygen, because they are 4 of them, I'm going to say plus 4. But like I said, because it's not combined with the peroxide or fluorine, it must be negative 2 for oxygen, okay? That's why I'm going to put a negative 3 here in brackets, okay? And then later I equate to 0, because there is no ion on that potassium permanganate. So what is 4 times negative 2? I get what? I get negative 8 all together. So I'm going to say minus 8 here, right? Equals to 0, okay? So from here, what is 1 minus 8? I get negative 7, okay? I get negative 7 equals to 0. So from here, as you can see, my Y, which is the oxidation state for manganese, is going to be what? It's going to be positive 7. So that's how we get the positive 7, which you see here. Hope we are together. Now sometimes if there is an ion like this negative 2, and I want to get for sulfur, oxygen here again is going to be negative 2. Are we together? So I can say that let oxidation state for sulfur be what? Bx, ne? Are we together? Bx. And then I know for oxygen it is what? It's minus 2. So if oxidation state for sulfur is X, I'm going to say X. Okay? Then plus. Now if you check here, there is a 4 here. That's, I'm going to say plus 4, open brackets. Then I'm going to put minus 2 for oxygen, because that's for oxygen. And now the ion is negative 2. So I'm going to equate to negative 2, people. I'm going to equate to negative 2, okay? Now what is 4 minus 2? That's minus 8. So I'm going to have X, okay, minus 8 equals to negative 2. So if I simplify it, so I'm going to say X equals to negative 2 plus 8. And what do I get in this case? I get X equals to positive 6. So in this case, the oxidation state for sulfur is positive 6, and that's how we get it here. Now this iron 3 chloride, now chloride is a halogen, so it's minus 1. So a minus 1. Now because this is iron 3, now that's going to be positive 3. That's why it's going to be positive 3 for iron here. Positive 3 for iron. And then what about for the chloride? We said it's negative 1, but because there are 3 of them, I'm going to say 3, open brackets, and minus 1, okay? Now surely if you add positive 3 plus negative 3, I get 0, which you see on top here. This is neutral. Hope we are together. Let us proceed, guys. Hope we are together. Let us proceed. Okay, now apart from that, we have to know how to represent redox reactions. Now, redox reactions can be shown in two half reactions showing the transfer of electrons. By the way, what's a redox reaction? It is a reaction which involves what? The transfer of electrons. So now we have two half reactions to show the transfer of what? Of electrons. There are two half reactions to show the transfer of electrons. Okay, this one is also called the electron method, as you're going to see in the questions. Now, these half reactions will include the oxidation half reaction and then reduction half reaction. Now, oxidation is the loss of electrons, like we said. If you look at oil, oxidation is loss of electrons. Now, if we lose in chemistry, it means that it's going to appear on the product side. So this X, to form X2 plus, it means we lost 2 electrons. That's why they are shown on the what? On the product side. So this is the half oxidation reaction, or you can call it oxidation half reaction all together. But if we gain, then it's called but not something, but it has increased from 0 here, by the way. Oxidation state of this X, it has increased from 0, okay, to what? To positive 2. Are we together? And then here, if you check with reduction half reaction, now I'm going to have Y plus 2 electrons to give me Y2 minus. Now, in this case, if we talk about reduction half reaction, then we must have our electrons on the reactant side. They must be on the what? Reactant side. That's why they are here. Now, in this case, as you can see that my OS has been decreased from 0 to 2 minus. Now, if we add these two halves, we get what we call as the net overall reaction. Okay, the net reaction. Okay. Now, this is what we do. Now, before we add the two half reactions, before we add them, we must make sure that the electrons are the same for the oxidation and reduction. Otherwise, you won't be correct. Okay. So in this case, this is 2 electrons. It cancels with 2 electrons here. So when I'm adding, I'm going to have X plus Y. That's what you see here, equals to X2 plus, then plus Y2 minus, which combine to give me XY. Are we together? So the 2 plus and 2 minus, they cancel out to make it neutral, which becomes XY. So in this case, no electrons must be shown in the overall net reaction. Let us look at examples here. Examples here, let's say, in the following equations, identify the oxidizing and reducing agents. Now, before we do that, we've got steps 1, 2, and 3. In step 1, we write all oxidation numbers for these elements, okay? Now, this is copper to oxide, so in this case, this is oxygen, it has got 2 minus. Then copper 2, that's a 2 plus here. What about hydrogen? Because a pure diatomic element is going to be 0. What about copper? It's also a pure element, it's also 0 here. What about water? Now here, because this is not hydrogen, this oxygen is a non-metal. What's going to be for hydrogen? Positive 1. Are we together? What about oxygen? Negative 2. Now in step 2, we identify the change in oxidation number for each element. If you look at copper, it's changing from positive 2 up to 0. From positive 2 to 0, meaning that it has been what? Reduced from positive 2 to 0. And if copper reduces from positive 2 to 0, it means that this copper is going to be the oxidizing agent. Let me explain again why. Because hydrogen has been oxidized from 0, from this 0 here to what? To positive 1 here, to positive 1. Now, who is oxidizing this hydrogen from 0 to positive 1? It is the copper. Copper to oxide. Are we together? It is copper to oxide, which is what? Which is oxidizing agent. That's why we are saying in step 3 that now the copper 2 ions or copper dioxide, we see that the oxidation number decreases and it means it has gained electrons. Okay, are we together? And so it's called what? The oxidizing agent. Are we together? Let me explain again. We are saying that because copper 2 has been reduced from positive 2 to 0, it's going to be oxidizing the other. That's why it's called the oxidizing agent. Which one? The copper 2 ion. Now at the same time, if you check properly, the hydrogen has been oxidized from 0 to positive 1. So as it is being oxidized from 0 to positive 1, itself is called what? The reducing agent. Which one? The hydrogen. So hydrogen is a reducing agent. Why? Because it has reduced the copper 2 to 0. From copper 2 to 0. Are we together? I think we deserve another example. Now look at oxygen. Oxygen, it is -2 and negative, so it did not change. Another example, guys. Another example here, part B. Nitrogen monoxide plus carbon monoxide to give us nitrogen gas plus carbon dioxide. In this case, oxygen is 2-, so nitrogen will also be 2+, because it must give us 0 when I add them. Then this is carbon monoxide. Now oxygen oxygen has got 2-, are we together? So carbon must be 2+. Okay, now check this. This is nitrogen, this is neutral diatomic element, so it is 0. Okay, and carbon dioxide in here. Now oxygen has got 2-, but there are 2 of them. Are we together? So 2 times -2, it's -4. So to balance the -4, carbon must be +4. That's why it is +4 here for the carbon. Okay, now if we check properly again, now in this case, nitrogen has been reduced from +2 to 0, which you see here, guys. And then what about oxygen? What about oxygen? Nitrogen from +2 to 0. What about oxygen? It is -2 and negative, so it remains the same. Did not change. What about carbon? It has been increased from +2 to +4. It has been oxidized from +2 to +4. That's our carbon. Are we together? Now check this again. Because nitrogen has been reduced from +2 to 0, it means it's the one which oxidized the carbon. So nitrogen 2 ions or nitrogen monoxide is called what? Oxidizing agent. At the same time, because carbon has been oxidized from +2 to +4, as it is doing so, it's going to be reducing the nitrogen from +2 to 0. So it means this carbon 2 ions or carbon monoxide is called our reducing agent. Hope we are together. If you're not together, please feel free, pause the video and watch it again. Alright, that was to identify the oxidizing agent and reducing agent. Now another part of this question which comes, they ask you to write the balanced redox reaction for the reaction. Let's say write down the balanced redox reaction, the overall. Are we together? This is what we do. Now if they give us something like a magnesium plus iron 2 sulfate to give us magnesium sulfate plus iron, we're going to first of all write oxidation numbers for each. Now magnesium being a neutral element here, it has got 0 oxidation state. Now iron 2 sulfate has got +2. Then the sulfate, sulfur has got +6, we saw that already. What about oxygen? 2-. Now this is magnesium sulfate. Now magnesium being a group 2 element and being combined, it's going to be having +2. Sulfur still has +6. What about oxygen? It has -2. Now iron, here it's not combined, it is neutral, so it's got 0. If you identify what is happening, we see that magnesium moved from +2 I mean from 0 to positive 2, I beg your pardon. So it has been oxidized from 0 to positive 2. What about iron? From positive 2 up to 0. It has been reduced from positive 2 to 0. So what about sulfur? Sulfur, it remained positive 6 and positive 6, as well as oxygen. Now together. So we identify these two which have had the change in oxidation states, meaning they have had the transfer of electrons. That's what we use to write our overall redox reaction. Redox meaning reduction and oxidation reaction. Okay. Now after that, in step 3, now magnesium has been oxidized from 0 to positive 2. We write it as Mg to give us Mg2 plus 2 electrons. It has been oxidized to Mg2 plus 2 electrons. Are we together? Now in your test, they give what we call as the standard reduction tables, which I'm gonna show you. This one you can get directly as long as you know the order. You should know that it was magnesium 0, now it was positive 2. Now the iron has been reduced from positive 2 to 0. That's why it is iron 2 ions plus 2 electrons to give us iron here. Are we together? Now if you check here, I have to add now the two half equations to get the overall, because this is positive 2 electrons and this side also positive 2 electrons this side. So when I cancel them, when I'm adding the two equations, I'm going to cancel the what? The electrons. Hope we are together. I cancel them when I'm adding the what? The two equations. So when I cancel, I'm left with magnesium plus iron 2 to give me magnesium 2 ions plus iron. That's how I get my overall reaction, which does not contain any electrons, or does it contain what? The spectator ions, which did not have a change in oxidation state, that is to say sulfur and oxygen. Hope we are together. Now this method is called the ion electron method of getting the overall net reaction. I think you deserve another example, don't you think so? We have one here. We have another one here. They say if you have zinc plus silver nitrate to give us silver plus zinc nitrate. Now check, zinc is a neutral element, so it is 0 oxidation state. Now silver, it has got positive 1. Okay. Then nitrogen, this nitrate has got positive 5. What about oxygen? Negative 2. To give us a silver, which is now 0 in this case. What about zinc? It is positive 2. What about nitrogen? It is positive 5. What about oxygen? It's minus 2. Now if I analyze the change in oxidation states, I can find out that zinc has been oxidized from 0 to positive 2, which I think you also see. What about my silver? It has been reduced from positive 1 to 0. What about nitrogen? It remained positive 5 and positive 5. What about oxygen? Negative 2 and negative 2. So it means these ones did not change, the nitrogen and oxygen. Okay. And then so for that case, I'm going to, it means my oxidation is going to be from zinc to zinc 2. What about my reduction is going to be from silver 1 to silver. So after that, then now I come and write the equation, that is to say zinc oxidized to zinc 2 ions plus 2 electrons. What about silver? Plus 1 electron to give me silver here. Now I must balance the electrons. So what am I going to do in that case? I'm going to multiply by 2 because there is a 2 here. I must multiply by 2 here, 2 here, and 2 here. Multiply by 2 throughout. That's how we get these 2 which you guys see here in this equation here. This 2 here is gotten by multiplying by 2 throughout. Okay, and this 2 here and these 2 are together. Now I can add this equation for the oxidation plus reduction, and I cancel the electrons because they are the same in number on opposite side. So it's going to be left with zinc plus 2 silver ions to give me zinc 2 ions plus 2 silver. I hope we are together. Now I said that in your test they give what we call as the standard reduction tables. We called what? Standard reduction tables. Now these reduction tables, they contain those half reactions. They contain oxidation half reaction and reduction half reaction. But I want you to note this. Okay. Now we are using table 4b. It's called standard reduction potentials. I repeat, it's called what? Standard reduction potentials. Now, because it is called reduction potentials, it means that the direction from left to right is going to be showing what? Reduction half equation. For example, this is lithium plus an electron to give us lithium, so this is called a reduction half equation. So if I want to write my reduction half equation, I must begin from this way. Now this arrow is double, but I must know what I want, so I put a single arrow coming like this, which means it's going to be now like this to give me the half reduction equation. It's going to be lithium ion plus an electron to give me what? Lithium, like this. Okay. However, if I want oxidation is the reverse of reduction. Remember our magnesium, it was being oxidized, remember? Now in this case, I write my equation like this. I begin from right going to the left. That's why it will be like this. Okay. Now you're going to say Mg arrow, then Mg2 plus 2 electrons. Okay. So which means that in your test and the exam, if you want to write the oxidation half reaction, begin from right hand side going to the left hand side. Now somebody can say, but sir, what if I put a double arrow? If you put a double arrow, you get it wrong because you are confusing us and also confusing yourself. Okay. Now this is ion 2 here plus 2 electrons. This one is also a reduction half reaction with 2 electrons. So basically this table is given to you in your exam to identify the reduction half reaction and oxidation half reaction, but bearing in mind that if I want to write down my reduction, it must be from where? From left to right. Are together? What about my oxidation? From right to left. Are together? So let us look at other examples. Hope we are together, guys. Let's look at other examples here. The question says here that now this question was asked in 2020 Eastern Cape, and they say consider the redox reaction given below. That is iron 3 ions plus zinc to give us zinc 2 plus iron 2. The question says define oxidation reaction in terms of electron transfer. Anybody who remembers what is oxidation? Oxidation is what? It is the loss of electrons. It is what? The loss of electrons. So oxidation is the loss of electrons. Are we together? That's our answer there. Now they say that write down the formula of the reducing agent. Now is it this one or this one? So to know what my answer is, I'm looking for a reducing agent. So the reducing agent is the one which must be oxidized. Are we together? If I check here, this is zinc, which has got a 0 oxidation state here. Are we together? It has got what? 0 oxidation state here. Okay. This is 0 oxidation state because not combined. Are we together? And what about iron 3? It has got positive 3 oxidation state. Are we together? Now check here. Now the zinc this side, it has got positive 2 oxidation state. What about iron? It has got positive 2 oxidation state. Are we together? So if I analyze, I can see, I'm looking for the reducing agent by the way. Now this is zinc has been oxidized from 0 to positive 2, which means the zinc Zn is called the reducing agent because it has been oxidized. So my answer is going to be what? It's going to be the zinc 2, the zinc just Zn. So Zn, zinc, is my reducing agent. Why? Because it has been oxidized. Somebody can say, what about if they wanted to find the oxidizing agent? Now, oxidizing agent in this case is the one which is being reduced. Let's check. Now, this ion 3 reduced to ion 2. Okay, from positive 3 to positive 2, it has been what? Reduced. So it means that this ion 3, this one here, this ion 3 is the reducing agent. Rather, oxidizing agent, sorry, is the oxidizing agent because it has oxidized the zinc from 0 to positive 2. Hope we are together. Now let's write down the reduction half reaction. Now this ion 3 has been reduced from positive 3 to positive 2. So now, if I don't know it in my head, I just know I'm reducing from ion 3 to ion 2. I go back to my table, I check at the back of the question paper and identify ion 3 being reduced to ion 2. Let's go there now. Ion 3 to ion 2. Now if I check properly, ion 3 to ion 2, where is it, guys? This is ion 3 to ion here. But I want ion 3 to ion 2, so is it up? Nope, it's not up, right? So we go down. So ion 3 to ion 2, you have to be very careful, don't rush please. If you rush, you crash. Hope you know that. Now if you check here, now this is ion 3 ions to ion 2 ions. Because we said from left to right is called reduction half reaction. So my answer is going to be ion 3 plus 2 electrons, but with an arrow pointing to the what? Pointing to the right. Because like we said, it must be from where? It must be from left to right. So this one is going to give me my what? My half reduction equation. Are we together? Now if I come back here, I'm going to have it here like this. Okay, I wrote it here already to avoid wasting your time. So this is my what? This is my reduction half equation. Okay. Now after that, let's proceed. What do they want next? Now they say consider the redox reaction below. Don't forget this was the reduction half reaction. Just put in the right place. It's here. This is the reduction half reaction equation. Okay. Now they say reaction below is silver solid plus nitrate to give us nitrogen dioxide plus silver ion. They say determine oxidation number of nitrogen N in nitrogen nitrate, in the nitrate. Okay. So now I'm gonna say let my oxidation number be any later that I'm going to use Y. I'm going to use what? I'm going to use Y. So if I use Y in this case, okay, I'm going to say that okay. So now if you check here, nitrate, the ion is -1, so I'm going to let it be Y for nitrogen. It's going to be now Y. Now what is oxygen oxidation number? We say it's -2, but because of the 3, that's why I'm putting a 3 here, then -2. After adding, I'm equal to -1 because the ion is -1 here, guys. Okay, so 3 times -2 gives me -6, then Y minus 6 equals to -1, which gives me Y equals to +5. So the answer is what? The answer is +5 for the oxidation state of nitrogen in the nitrate. Are we together? So what's my answer again? My answer is what? My answer is +5. My answer is what? +5. Hope we are together. Let us proceed. So that is oxidation state for nitrogen in the nitrate, which we said is +5. How did I do it? I said let Y be oxidation number for the nitrogen. Then I see that my overall charge is -1, so Y plus 3 open brackets -2 must give me -1. If I simplify this, you see I get positive 5, so that's my answer. Now they say balance the above chemical equation using ion electron method. Now after identifying oxidation states, let's check them again properly. Now we know that silver, because it is what? Because it is not combined here, it has got 0 oxidation state, right? That's why it has got 0 oxidation state here. So this is 0 oxidation state for silver. What about nitrogen? We saw it is positive 5 altogether, positive 5 here. What about oxygen? We saw it was what? We saw it's negative 2, but there's a 3 here. That's now negative 2. Okay, so 3 into negative 2. Okay. Now note that if I say 3 times negative 2, I get negative 6. Negative 6 plus 5, I get negative 1, which is here already. All together. What about nitrogen now? Now this is nitrogen dioxide. Now I don't know oxidation state, right? So what am I gonna do? I'm going to find out that if I let it to be X for nitrogen, okay, I'm going to say it's going to be X, okay, for nitrogen altogether. What about oxygen? It is 2 minus, ne? Okay, it's going to be, now because of the 2 which is here, I'm going to multiply by 2, okay. Then because there is no charge, I equate it to 0, okay. So 2 times minus 2, it is what? It is minus 4. So X minus 4 equals to 0, which gives me nitrogen to be what? To be positive 4. So this is positive 4 for nitrogen. Are you together? What about oxygen? We said it was minus 2. Okay. What about silver here now? You see, we said it's positive 1 from our rules. Okay, this is positive 1 here. Now if you check here, silver has been oxidized from 0 to positive 1. Are you together? What about the nitrate ion? It has been reduced from positive 5 to positive 4. Are you together? Which means that the silver to silver ion gives me the oxidation half reaction, which you see here, guys. And then the nitrate to nitrogen dioxide gives me the reduction half reaction. Now please pay attention here. Now to know the products here, you go back to your table at the back of your test and you check. You must keep in mind the reactant and the product. I have nitrate to give me nitrogen dioxide. So if I check properly my table 4b again, my table 4b, I can see that the nitrate has got there 2 of them. This nitrate gives me nitrogen dioxide. What about here? Nitrate gives me what? Nitrogen monoxide. But because I have nitrogen dioxide in my question as the product and nitrate as it means I must take this one here. So I write it as you see it here to be my what? To be my reduction half equation. Hope we are together, guys. So in that case, don't forget what we said. We said that you must do what? You must put a single arrow, and if you want to write a reduction, we said it must be from where? It must be from left to right. So I'm going to write it exactly like this, but my arrow will be like this now, okay? My arrow will be like this. Now somebody can say, do you include everything which is here? Yes, I put everything which is here. I'm going to say nitrate plus 2 protons plus an electron to give me nitrogen dioxide plus water. I don't write it on here. Why? Because this product is different from the one which is in the question. Somebody can say, what if I use it, sir? You don't get marks because you are setting your own question. Let us proceed. Now if you check also for silver, let me show you for silver here. Now for silver, let's check it here. It was oxidation, It was what? Oxidation. That was from silver Ag to silver Ag plus, okay? If you check here, in that case, we have it, where is it? Silver Ag to Ag plus. Do you have it anywhere? Is it here? Silver to silver Ag plus. Where are you? Yes, thank you, Jesus. It is here. Now, because silver underwent oxidation, now it means it's going to be facing this direction now. So, if I'm drawing my arrow in that case, it's going to be facing this way. I'm going to write Ag, then I draw the arrow facing this way like this. Okay, and then I must put the arrow facing to the what? Like this. So I'm going to start with the Ag, arrow, silver, Ag plus plus, and electron. So you see this is one electron. What about here? That is also one. That's good. So I'm just going to add them and cancel out electrons to get my overall net reaction, which is called the ion electron method. Let's proceed. So if you check here, these electrons are going to cancel out here. Okay. And so they're going to cancel out. So as I add them, now I'm going to have this silver Ag. Okay. Let's write it properly. We're going to have silver Ag with so that's the Ag which you see up here, which you see here, guys. This Ag here is what you see here. So I'm going to say my silver Ag, right? Silver Ag. Then now plus this nitrate, that is NO3. NO3 with a minus. Are we together? What about the protons? Plus 2 protons. Okay, plus 2 protons. Okay, now these protons, they show that this one was taking place in the acid medium. Then this side I have what? To give me, what do I have? I have Ag plus, that is silver Ag plus. Okay. And then plus what? Plus nitrogen dioxide. Plus nitrogen dioxide. Okay. And then plus what? Then plus water, which is H2O. Which is what? H2O. Let me say something. If you check here now, this positive one here, this is positive one is the overall charge on the products. What about reactants? Now this is positive 2 because of this 2 here. Positive 2 plus negative 1 gives me positive 1, which means the charges are balanced, and hence my net equation is right, because everything must balance. The charges must balance, as well as what? As well as the ions are together. So that is the example there which we have. We deserve one more example, right? Let's check it out. Now this one was asked 2019 Eastern Cape. The question said that the reaction between magnesium and the hydrochloric acid is an example of redox reaction. The balance equation is this one here. Magnesium Mg plus 2HCl to give us Mg chloride plus hydrogen gas. Define oxidation in terms of electron transfer. What did we say is oxidation in terms of electron transfer? Anybody who remembers? We said oxidation is what? Loss of electrons. So oxidation is loss of electrons. Let us continue. Let's write down the formula or symbol of a substance whose oxidation number does not change during the reaction. So because we don't want to guess, we have to calculate them out. Okay? There's no change in oxidation number. Let us find out now. With magnesium, because it's not combined, it's neutral, it's going to be having 0 oxidation state. So that's why I'm putting a 0 here. So this is 0 for magnesium, right? Okay. Then HCl. Now Cl is a halogen. It's going to be having negative 1. What about hydrogen? It's going to be also having positive 1. So positive 1 for hydrogen and negative 1 for the Cl. Now magnesium chloride here, magnesium being a group 2 and being combined, is going to be having positive 2 here. So this is positive 2 for magnesium. Are we together? What about chloride? It's negative 1, but there are 2 of them. So it's going to be this 2 into negative 1, so they can balance properly. Okay. What about hydrogen? Now it's not combined, so it's going to be now 0 here. Okay. Now if you check here, the chloride is negative 1 What about here? Also -1. So it means chloride did not have a change in what? In oxidation state. So that's my answer here. So let's write down the formula or symbol. So I'm gonna say the chloride, that is Cl minus, did not have what? A change in the oxidation number. Let us proceed. Now they continue, so that write down what? Write down the symbol of the reducing agent. Explain the answer in terms of oxidation numbers. Now, reducing agent is the one which is oxidized. So, magnesium was oxidized from 0 to +2. So, it means this Mg is what? Is the reducing agent. Are we together? Mg is the what? Reducing agent. Why? Because it has been oxidized. That's the reason. So it is what? It is Mg. Mg is the reducing agent. Now somebody can say, what if I write what if I write what? What if I write Mg chloride? That's not correct. It must be this Mg because it has got to 0. It was oxidized from 0 to +2. So this one which was oxidized is called reducing agent. Let's explain your answer. You say because it has been oxidized. Let's write down the balanced reduction half reaction. The balanced reduction half reaction. Now, reduction. You see this hydrogen has been reduced from +1 to 0. So that's what we're going to write, okay? Like I said again, you can check if you want the table, but don't forget it must be from where? From left to right, that is for reduction. So hydrogen, if you check properly with hydrogen, it is here. So maybe now 2 hydrogen ions plus 2 electrons to give us hydrogen gas. This is called what? The reduction half equation. Okay. Hope we are together. Hope we are what? Together. So we said is what? It is reduction half equation. So to avoid wasting your time, I wrote it here down already for you guys. So that's what you see here. So this is the reduction half equation or half reaction. Okay, then next they said that in another redox reaction, ion 2 is oxidized to ion 3 ions by dichromate ions in acidic medium. The dichromate ions are reduced to chromium 3 ions. Write down the balanced equation for the net redox reaction by using the ion electron method. Show all your steps in the balanced equation. Okay. I repeat, they say, in another redox reaction, ion 2 ions oxidized to what? To ion 3 ions by dichromate ions. So, oxidized from ion 2 to ion 3, that means electron undergoes what? It undergoes the oxidation half reaction. We said from the start that if you look at our table 4b, oxidation from where is from, we said from right to left. So it's going to be, because we are oxidizing, it's going to be from ion 2 to ion what? Ion 3. Okay, so it's going to look like this one here. So this is ion 2 to ion 3 has been oxidized. Okay. That's going to be our oxidation half reaction. Okay, are we together? Are we together? Are we together? That's oxidation half reaction. And then, what about the dichromate? Let's say the dichromate, what happened to it? He said that it was reduced from dichromate ions to what? To chromium 3 ions. So after having this oxidation half reaction, now the dichromate ions are reduced to chromium 3 ions. So again, you check in your table 4b, you must look for dichromate ions being reduced to chromium 3 ions. Let us check there. Dichromate ions to chromium 3 ions. Okay, let's check. Now if you check here again, we have the dichromate ions reduce to chromium 3 ions. Okay, so we have plus 14 protons plus 6 electrons to give us this one here plus water, because we're writing down a reduction half-full equation. Where will the arrow face? It's going to face this way or this way. We said it must be from where? From left to right. So it's going to come like this. We said if you put a double arrow to confuse the teacher, lose all your marks. So don't be so creative. So write everything the way you see it here, all together. And then together with the other one, which was for iron what? Which was for iron 2 to iron 3. Let's check it here. Iron 2 to iron 3, that was oxidation. Iron 2 to iron 3. Now if you check here, this is iron 2 to iron 3. Now it means I'm going to change my arrow from right to left, okay? So it will be like this now. So in this case, I'm going to write a single equation, but I'm going to have it from where? From right, like this, going to the left now, okay? So that's now called the oxidation half reaction. So if you check here, this is plus 1 electron. What about for the sake of the dichromate, guys? What did you see? What did you notice with dichromate? Now dichromate has got 6 electrons. So because this is only 1 electron here, I'm going to multiply this equation by 6 so that I can balance the electrons. That is how the ion electron method works. Let us proceed. Let us proceed. Now if I proceed again, I have this one is like you see, I'm going to multiply here by what? By 6, like we said. Multiply by 6. So if I do so, I'm going to have something like this now. So after multiplying by 6, by 6, by 6, and I add on for the dichromate to be reduced. Now check here, because I have 6 electrons, okay, here on the products, and the 6 on the reactants, they're going to cancel out. So I can cancel them out. After cancelling them out now, it means I can add to get my overall reaction. So what's my net? My net is going to be like this. I'm going to have the 6 iron 2, which you guys see here, the 6 iron 2. This is 6 iron 2 here, which I think you can all see. I'm going to say 6 iron 2, 6 iron 2, okay. And then plus what? Plus the dichromate ion, plus dichromate ion, plus dichromate ion, that is 2 here. Then O7 with the 2 minus, okay. Then plus 14 protons, okay, plus 14 protons, 14 protons here. And then to give me what? To give me this one here. This one, it is 6 iron 3, right? To give me 6 iron 3, 6 iron 3, okay, 6 iron 3, and then plus what? Plus 2 chromium ions, plus 2 chromium ions, chromium 3 ions, okay. Then plus what? Plus 7 water, plus 7 water, plus 7 water. Okay. Alright, I hope guys we are together. Let us check the ions. Ne? What is 6 times positive 3? I get what? I get 18. Ne? What about 2 times 3? I get 6. What is 6 plus 18? I get 20 what? I get 24. Are we together? Let's check it again. What is 2 times 3? I get 6. I get 6 here. What about here? 6 times 3? I get 18. Now this 18 plus 6 gives me what? It gives me 20, 24. What about this side? This is positive. This is 14. Now what is this? Is 14, right? That is 14 here. Now 14 minus 2, I get 12. I get positive 12 here. What about 6 times 2 is also 12, which means I'm balancing. 12 plus 12 is also 24. So it means the ions are also balanced, which means I am correct because I've got positive ion for the products and reactants. So this is our final answer, guys, for writing down the net overall reaction using the ion electron method. I hope we are together. Yes, my name once again is Patrick Kamala. I am a tutor and educator for mathematics and physical sciences, grades 10 to 12. Now, these are questions for you to try out. This was 2019 DBE. Try it out, please. Try it out. When you are done, something else for you to try. And this one here. It was also DBE 2017. Try it out. I'm sure I will enjoy it. This was 2018 also DBE. Try it out, please. Try it out. When you are done, lastly, this one here, 2019 November DBE. Try them out. Now this one is about acids and bases, to do with the conjugate acid-base pairs. If you find any challenges, you can inbox me on this number here, this one here, so that I can give you the video to watch about acids and bases. Then you try out you can pass this question. However, if you don't mind, you may come to our tuition center here in town at Rosteke College, Polokwane. Yes, and support us with your 500 rands per month. Thank you so much for watching. Catch you again in my next video. Bye bye. Take care.